This is chapter 2-6, proving statements about angles. In chapter 2-5, we prove statements about segments. This time it's just about angle. The reflexive property, AB is equal to AB. Now it's going to be dealing with angles instead of segments. So angle A will be equal to itself, angle A. So angle A will be equal to angle A. We did the symmetric property, for example, segment, when we were doing segments, segment AB was equal to segment CD, and then the symmetric was segment CD is equal to AB, so we wrote it in reverse. This time we'll be dealing with angles. For the symmetric property, it will be angle A is equal to angle B, and the symmetric will be angle B is equal to angle A. Please copy your codes. In this particular area, we still got a whole lot more theorems that we need to learn. And the question is, have you been studying and memorizing the old ones? You need to make sure that you're doing that. Just a reminder, all the lessons that we've been doing are coming straight out of your geometry textbook. So please make sure you refer to your textbook. These are the notes from your books, from all the chapters, chapters 1 and 2. So refer to your notebook. Also take notes there as we go through the lessons. Theorem 2.2 is where we're going to start. And with Theorem 2.2, and again, this is going to look familiar because we did this with segments. Now we're doing with angles. Theorem 2.2 deals with properties of angle congruence, and they can be reflexive, which we did before. Where we had this time it'll be angle A is equal to angle A. If we're talking about angles, symmetric will be, example will be angle A is equal to angle B, and then the reverse will be angle B, meaning is equal to angle A. And then, of course, transitive, which we dealt with before. On this one, it will be angle A is equal to angle B. Then angle B is equal to angle C. Then that means that the first and third. So the first and second are equal. The second and third are equal. Therefore, the first and third will be equal. So angle A will be equal to angle C. We've done it. This is old stuff. We just done it with segments. Now we're doing it with angles. Okay? And here's our examples, as I've stated up there. Reflexive property for any angle. If I'm talking about angle A is congruent to angle A. Symmetric, angle B is congruent to angle B. Then that means that angle B is congruent to angle A. And transitive, if angle A is congruent to angle B, if the first and second are congruent, then the second and third are congruent, then that means that the first and third will be congruent to one another. Alright, some definitions. Definitions you want to commit to memory. Congruence postulates have the same measure. And actually I'm going to jump around here. Just a little bit, you'll see in a minute. Okay, let's go here. Theorem 2-3, the right angle congruence theorem, which says that all right angles are congruent. Listen, I don't want to hear that looks like that. We talked about the looks like. This first angle looks like a right angle. But if it does not have the marker in the corner, you cannot say that it is a right angle. It must have a marker in the corner, or in the written direction, they must say, this angle here is a right angle. If it does not say that, you cannot tell me this is a right angle because it looks like. It must have the marker, or it must say that this angle is a right angle. Okay? But the congruence thing says all right angles are congruent. So, angle A, back up just a little bit. Angle A is congruent to angle B. They are the same measure because both are 90 degrees. It doesn't matter if they're going in the same direction, which they're not. Okay? Angle A appears this way, and B appears to be this way. But the important thing is the angle measures are congruent because they're both right angles, and we know that because of the markers. Okay? Let's recall some information that you should remember. Here's the definition of a right angle, which you need to commit to memory. Okay? Right angles are equal to 90 degrees. Please make sure you remember that right angles measures equal 90 degrees. Here's a theorem for you. Theorem 2.4. I'm moving to the next theorem. That was 2.3, which is the right angle. Please don't remember necessarily the numbers, because remember we talk about different books. If you will go to a different school district or what have you, they may use a different book. The theorem numbers may be different, but you need to remember the name. So this next theorem is 2.4, but the name of it is the Congruent Supplements Theorem. And the definition of this one is, if two angles are supplementary, you need to remember what supplementary means. Two or more angles equal 180 degrees. So if two angles are supplementary to the same angle, or they congruent to the angles, then they are congruent. What do you mean? Here's simply what I mean. If the measure of angle 1, which is here, if the measure of angle 1, this angle here, plus the measure of angle 2, added to the measure of angle 2, is equal to 180 degrees, and I know that if the measure of angle 2, this angle 2, or I rewrote it down here, the measure of angle 2 plus the measure of angle 3, a new angle, is also 80 degrees. That means I'm using the same angle measure of 2, so if it's 110 degrees, that means that the measure of angles 1 and 3 are congruent to one another. I'll back up again. If the measure of angle 1, this angle here, plus the measure of angle 2 is equal to 180 degrees, and I know that the measure of angle 2 plus the measure of angle 3, that's also equal to 180 degrees, that means that angles 1 and 3 are congruent to one another. Why? Because angle 2, its value didn't change. However, we still see that adding angles 1 and 2 give 180 degrees, and 2 and 3 give 180 degrees. So this is 110 degrees, and this is supposed to equal 180. You can know by subtraction that this angle here is 70 degrees for the measure of angle 1. And if the angle measure 2 plus the measure of angle 3 is equal to 180 degrees, and angle 2's value still has not changed, it's still equal to 110 degrees. 110, that's supposed to be 110. That means that because these two angles equal 180, I can just subtract and find that angle 3 is also 70 degrees, which is the same value as angle 1. Okay? Now, that goes the same thing. I can do that with the complement. Remember, complement is two or more angles equaling 90 degrees. Okay? Supplement, two or more angles equal 180. Complement, two or more angles equal 90 degrees. This theorem is just like the supplement theorem. The only difference is when I add two angles and they are complementary to the same angle or congruent, then the two angles are congruent. What do you mean? If the measure of angle 1 plus the measure of angle 2, whatever they are, is equal to 90 degrees, and I also know that the measure of angle 2 plus the measure of angle 3 is 90 degrees, I know that the measure of angle 1 and 3 are congruent to one another, because the measure of angle 2 will remain the same. So then we have, again, angle 1 is congruent to angle 3. Okay? And while I'm here for just a moment, so I have here the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees because they're complement. These two together. And then if I take the measure of angle 2 plus the measure of angle, and this was angle 2, if the measure of angle 3 plus 2 is also equal to 90 degrees, these two values, the measure of angle 2, don't change. So that's still equal to 90 degrees. That means angle 3 and angle 1 are the same value because the measure of angle 2 will not change. Okay? Next, postulate. Postulate 12. We did linear pairs. Remember, that was two, we were looking at two angles form a linear pair or a straight line, or they equal how much in degrees? 180 degrees. So that means that the measure of angle 1 plus the measure of angle 2, if it's a linear pair, will equal 180 degrees. So what does that look like? The measure of angle 1 plus the measure of angle 2, because they form a linear pair, they must equal 180 degrees. Okay? Angle 1 plus angle 2 is equal to 180 degrees. Okay? Finally, vertical angles. Vertical angles are when you have intersecting, here's my intersection here. Vertical angles are congruent. That means angle 1 and angle 3 are the same measure. So if angle 1 is 17 degrees, that means that the measure of angle 1 is equal to the measure of angle 3. That's all, both are equal to 17 degrees. That means that angles 2 and 4 are congruent. Now look at angles 1 and 2. They form a linear pair. 1 and 2 form a linear pair. So if I know that angle 1 is 17 degrees, I can find the measure of angle 2, 180 degrees minus 17 degrees will tell me that value of, or the measure of angle 2. So 180 minus the 17 degrees will tell me the value of the measure of angle 2, okay, which is 163 degrees, okay? And angle 2 and 4 are vertical pairs. They are across from one another, okay? Please make sure you study that in your notes.